I think we'll go ahead and get started. Thanks for joining us today. We have a really exciting session. I'm going to do a little bit of the talking, but I definitely have the privilege to be here presenting with RK and Alex. They're from Booz Allen, and they're going to be talking about how they're leveraging AWS and Tableau to build a workbench. Really, how can you build a workbench to streamline the challenges you have with doing data analytics? A lot of the different roles and challenges that a lot of customers face, they have a lot of great tooling that they're helping a lot of our public sector customers with. So my name's Ben Snively. I'm a specialist SA out of AWS. My specialization's in data and analytics. I've been at AWS for about 2.5 years. And then I wanted to go ahead and have RK, he's going to jump on the stage here and give some background. Thanks, RK.
Thank you. Can you hear me? Okay. Thanks. Good afternoon, folks. I know it's late in the day and trying to get to a pretty interesting topic around data science and data science tooling. You got to be really passionate about the way we are to kind of come and be here to talk about this topic. I'll let Alex introduce himself. My name is RK Palladru. I'm a principal with Booz Allen Hamilton. I lead data analytics for the federal civilian market, minus health and justice, homeland security, and transportation, which includes all of finance agencies and some of the economic development agencies. Our purpose here is today really share about our vision around where we got started a couple of years back around how we've, as a firm, invested in data science capability, right? So we support our federal sector clients, public sector clients, and one of the biggest challenges we've seen is how do you scale data science talent, right? So coming out of the challenges that we've faced, right? I mean, we have one of the largest strengths in terms of data scientists as a consulting firm. And what we've learned in the process of actually implementing solutions for clients is what resulted us to start thinking about how do we look at creatively the data analytics lifecycle, data, and the infrastructure and all that good stuff, right? So let me start with saying that, the first thing is the world needs insights, right? I mean, we all crave to have better outcomes. We need insights. So, the world is driven by insights. We believe deeply as a team, even within Booz Allen, particularly my team, we believe in that the world needs insights and it needs accelerated insights. So how do you get there, right? I mean, first of all, to affect outcomes, you really need to imagine outcomes, right? What do you want to achieve, right? And then you got to go about accelerating insights, right? I mean, the whole process is pretty inefficient, and that's some of our learning we've seen with just getting in data scientists to solve a problem. You can't scale data scientists because there are motivational issues. There's simply no supply in the market. How do you kind of use capabilities that could accelerate insights? And then finally, how do you really make it real, right? How do you enable action? How do you make it real? So why is accelerating insights really important, right? So when we look at our federal client base, particularly from the vantage point of where I sit, we see a lot of this has got to do with what our federal clients care about, right? They want to deliver citizen-centric services, right? They want to, that could mean anything about, efficient online services, whether it's an IRS or if you're talking about FEMA or emergency management assistance elsewhere, right? So there is that citizen touch point. Citizens are expecting that level of service that they've used to in the commercial world. The other side of it is to protect the safety and security of our country and the communities, right? I mean, we could talk about our defense and intel business, but I'm not going to get into that. But really around, things like, how do we protect consumers around predatory lending practices, right, with the Consumer Protection Financial Bureau or other kinds of regulatory agencies that we work with at the SEC. We have to promote the health and welfare of the citizen, right? I mean, though I don't cover those markets, but essentially it is about how do we get our agencies like the CMS and NIH and the customers we have out there leverage data and kind of insights to drive better performance, be it in efficient delivery of healthcare services, right? Or, payments associated with it or tackling and dealing with waste, fraud, and abuse. And then finally, facilitating economic opportunity, which is about, Department of Labor. How do you spur investments and training to kind of make sure that, our workforce is trained to kind of the 21st century jobs, and how do we enable those things? So all of this requires insights, right? So I'm constantly with a lot of our public sector clients, and most of the time we deal with these mission problems and we're looking for insights. And data is a big driver, insights is a bigger driver. So what has it got to do with now the kinds of trends that is impacting out there, right? I want to take a minute to tell you what's really changing, right? I've been in this industry for the last at least 17 years only doing data, right? And one of the things that I've seen is the classic way we've looked at it is, we'll collect data and we'll process it and we'll disseminate insight, and lo and behold, the whole world changes, right? I mean, and that's a very utopian way of looking at data. What we are increasingly seeing is certain strategic trends are influencing this, right? So first of all, there's changing skills and culture. Kids coming out of school today are wrangling data sets, right? I mean, they're pretty savvy in terms of getting it out there, using an R or Python to kind of pull in data, wrangle it, and deliver insights. Emergence of self-service. Business users are no longer happy with just canned reports. They want to have self-service dashboards. If they're a little more power user kinds, they could do some multidimensional modeling analysis with tools like Tableau, right? There's the widening spectrum of analytics, right? I mean, when I grew up, I was thinking about things like, descriptive and diagnostic kind of reporting, right? I mean, how do you drill through reports and information to kind of get to where you wanted to? IT prepared it and gave it to us, right? But today you have folks, we are clearly getting into the modeling and the deployment and the predictive and the prescriptive patterns of this, right? I mean, you could go to NLP and machine learning and all those things that are just extensions of how people are actually putting the power of analytics to kind of forecast and act and predict and act. I don't have to touch about big data drivers. We've always seen about the volume, variety, velocity, and the like, but that's a big driver. The technology is kind of scaling up. You see more commoditized hardwares coming in and starting to stand up and enable the kinds of things you could never do. You have machine learning, obviously. I don't need to talk about this. I'm sure there are a lot of others who have spoken about this, how you're able to kind of let machines compute on data sets and let you know what you're really trying to achieve. And then finally, that's an important part, right? Analytics moving to the data layer. I mean, this is about, there was a time when we all brought in data into our Excel spreadsheets and analyzed it, right, into the memory. But today, your analytical workloads are being increasingly sent out to where the data resides, right? I mean, like talk about Amazon REDSHIFT or like, your MapReduce and on HADOOP clusters. So these are some of the trends, right? So as these trends change, it's evolving, it's influencing the way the life cycle is evolving, right? So gone are the days where you just kind of collected data, processed it, and disseminated insights for the world to just come there, drink the insights and act upon it. So what you really have right now is the need to kind of define a business problem, right? You need to first define a business problem. There's things that you need to do. You got to then go about discovering data, right? This is what data scientists do, right? They're discovering data, and then they're curating it, they're just sharing it. Almost somebody we'll be talking about it. The Selfish product line, which we talk about, the Pinterest for data, right? Which is almost like I'm a data scientist. I discover this, I curate this data sets, I'm cleansing it, and I'm putting it out there. And then, somebody else sees that information, knows I'm the subject matter expert, likes it, reviews it. So now you almost have like a Pinterest of this notional container of data sets, or it's not the actual data, but the linkage or the reference to those data sets that's shared by data scientists. These are things that people have always been doing. People have spent sending CSV files and Excel files across to data scientists exchanging, but this is happening in a more accelerated realm, which I'll let Alex talk to it. Then we wrangle data, right? We wrangle data in terms of the way we want to kind of cleanse it, dedupe it. Gone are the days where we've always thought about IT kind of running ETL processes to transform this data. Yes, there is a big portion of that happens at the base end of it. But as you become very nimble at the front end, right, data scientists are wrangling these data sets the way they want to in the tools of their choice. You build analytical models, right? They build these analytical models. It could be fraud detection models. It could be customer behavior prediction models or citizen behavior prediction models. They deploy it, and then they look at validation and testing of these models. So let me tell you what a testing happens, right? So let's say you build a model we work with one of our customers in the on the IRS side of the equation. So where we build models. So one of the models is the model says what's the kind of fraud prediction we want to do, right? One of the biggest thing is we want to enable what I call as minimize false positives, right? I pay my taxes, but I would not want to be pulled up. The last thing I want is to be pulled up as a false positive of a fraudulent filing or an ID theft filing, because that's going to really kind of piss me off, right? So how do you build a model, but also as you build the model, how are you testing this model for its validity, for its ongoing performance? Fraudulent actors act in different ways, So there are interesting things like, I'm not an expert in this, but I can tell you that there are interesting predictions that our folks have done. Filings from certain zip codes where there are prison codes tend to have a higher correlation to a fraudulent filing, right? Now, would that be a constant thing? No. People are going to be like, the bad actors are going to keep changing their mechanism, right? So you're constantly building your models to evolve, and you got to test those models, and as you port them into production, is the model performing the way it is so that you can act upon it? And then finally, you got to be able to visualize it, and that's where tools like Tableau and other kinds of tools enable you to kind of visualize or consume this information and be able to act. So this is a life cycle that goes on. This is the day of a data scientist, right? But as you go through this data science experience, most of these folks are really struggling, right? I think they have a big problem with inefficient and cumbersomeness of this data science life cycle process, right? It has drawbacks. 79% of the data scientists spend their time in data preparation. There's like, 4/5 of your time is spent in preparation. Only 1/5 is spent in actual value out of it, insights and analysis and insights. It's suboptimal experience. Tell me, I'm all the time I'm hiring data science talent, and one of the biggest challenges, if I bring the data science talent into the door, the next minute, if they're not happy with what they're doing, if I put them on anything that is about wrangling data and preparing data, they say, bye, RK, goodbye. I'm going on to do my cool work. That's how the scientists are. They're expensive. They're not easy to find. So when we bring them into the door, how do we make that experience better if they're spending most of the least enjoyable part of their work is data preparation. That's where they're spending most of the time. So really, we're talking about this as the ability to build a unicorn, right? So we need a unicorn, right? We call it the purple unicorn or the data unicorn here within our team and within the firm, where we talk about the need to combine 3 different types of skill set. Why is this process broken? Why is it inefficient, right? There's the need for somebody who understands the problem. The business analyst, the classic business analyst understands the domain and the problem, but he or she does not understand the tools and the techniques of what a statistician or a data scientist brings in, or that of a data engineer, what he or she does, in terms of preparing the technology and the data to kind of make this possible. Then you have the data scientist who doesn't understand the other 2 realms, right? Who doesn't understand the domain and doesn't understand the technology and the data as much, right? Some of them are sophisticated, some of them are not. And then finally, you have the data engineers who are pretty good in running ETL programs and containerizing data and hosting it in the cloud and keeping it ready. But, they don't have the context about how you bring it. So really, we call this as bring your own problem, right? You bring your own problem so that you can find a solution. You got the data scientist bringing his own tools and techniques. And then the data engineer is kind of bringing in his own data sets. It could be open data sets, closed data sets, whatever. So for you to blend this is the only way is this process going to become more efficient, better user experience, and going to be really having throughput for all your data science investments. And so we came up with this Booz Allen Workbench, and I'll let, just go through it at a high level. So we've broken this down by steps. Your ability to kind of storyboard and annotate, right? There are tools that do this, right? That define what your business problem is, prioritize it, annotate it, and do things like that. But also there's a huge degree of collaboration and workflow, right? There are tools in the market today that let you do some collaboration, workflow kinds of things. There's discovering data. Data scientists are constantly going and searching, they're looking at catalogs, they're looking at business glossaries to understand semantics of data, they're searching for it. How does a tool suite kind of support all this, right? No single tool can solve this. I can tell you that with confidence, no single tool can solve this, even though I'm here as a customer of Tableau and AWS. AWS is the infrastructure, but when it comes to tooling, Tableau is not the only tool. Tableau is a very purpose-built tool to do certain things. So you need other kinds of tools. Data curation, I talked about this Pinterest mechanism to kind of tag and share data, right? How do you enable that? Collaboration, workflow, we talked about it. Wrangling data. I'm sure you've heard about business user data preparation is becoming a big portion of the market. If you have not already check out tools like Trifacta, Paxata, DataWatch. These are highly, highly nimble tools where the power of the traditional transformation part of your ETL processes is now being put into data scientists and business users, right? They're becoming very savvy in terms of doing data wrangling from a business user perspective. They understand the semantics, they understand the data, so they do it themselves. The great part of it is once all that is done, you can actually push of a button, you can push it into your traditional Informatica or your Apache NiFi, whatever types of workloads for you to automate that process, right? So we have those kinds of needs out there. Then there's the data science toolbox, right? Some guys want to come with Stata and MATLAB and Jupyter for Python workloads and RStudio for R. People want to come in with bring your own tools, right? I mean, scientists want to come with what they're familiar with. For me to kind of enable a project, to cross-train people is going to take time. So this is what bringing your own tool, letting you do what you want and interact it with the data sets is what accelerates that cycle. Code and algorithm reuse. GitHub integration, being able to kind of go and search their algorithms, their code for importing into their particular refinement of those algorithms, or further, there's the need to kind of host it. They then model these analytical models, right? I mean, they could be Bayesian models or regression model, linear or logistical regression models. Once they build it, they also want to share these models, right? So you can share the code, you can share the models, there's the whole governance around it, right? So how do you make that happen? How do you deploy and test it? We talked about some of that. And then there's finally the gallery, right? People want to showcase. I mean, we built this workbench, and we went to everybody and said, we want to show this to our clients, So the data scientists want to do the same thing. As they build these solutions, they want to deploy it in a gallery that they can showcase. Here's what the actual solution looks like. So we've had things like, space optimization solutions, right? Call center optimization solutions. We've done food stamp effectiveness for USDA, the Supplemental Nutrition Assistance Program. So these are all capabilities or solutions that we've built inside this capability that can be hosted, shared upon. We could publish infographics. We could deploy these models. You could ask questions on these models. You could go all the way from rudimentary dashboards to more sophisticated answers on demand or asking these analytical models. So I'm going to switch here briefly. So the workbench that we have built, right? I mean, this is actually up and running right now. We have this integrated. We have gone past a minimum viable product. We have a certain set of capabilities that are already, Tableau is deployed. It's deployed on Amazon REDSHIFT. So it goes all the way from the storage to the processing to visual. So when you look at the storage, right? So we have the open data platform. That's our open source implementation of the big data cluster, right? I mean, around our HortonWorks Hadoop implementations, we have Elasticsearch, we have Apache and NiFi it's the open source suite of capabilities that builds up this big data infrastructure, all running on the Amazon infrastructure out there. The other thing is we have what is called as a data lift, right? And I will let data lift to talk a little later. It's about how do you containerize or contextualize data that's inside your big data platform or elsewhere in a data warehouse. How do you contextualize it, right? You need that for pure data science to happen. Then I'm not going to talk about the Amazon REDSHIFT and the Jupyters. I just talked about the analytical analyze portion. And then you have finally, you're familiar with Tableau, but we're also going to talk about some of our Sailfish product here. I'll let it now to Ben to talk about.
So thanks, RK. So what we're going to do next is talk a little bit about some of the services that are powering some of the workbench. So the workbench is really enabling you to have that purple unicorn, fill various roles, bring in your own data, your own analytics, your own tooling. What are some of the common tools that we see within the workbench? The first is Tableau. So Tableau is a really fantastic business intelligence software. It runs really, really great on AWS. There's multiple ways to integrate Tableau with AWS. There's quick start guides, quick launches in order to launch either Tableau desktops or Tableau servers. And it's really, really easy to connect it to a wide number of data sources. And we'll talk a little bit more about that here. The first is VizQL. So VizQL is a query language to be able to declaratively define a query. And the really nice thing about this is, one, you can define your query very easily, but then that query maps directly to the database query languages to make it fast and very easy to trace. Within there, you could really unify the query to the visualizations that the queries are performing. So there's a nice mapping between those queries, that query language, and the visualizations that either might be a pre-built dashboard or in that self-service nature that RK was talking about, people are building dashboards on these data sets. Within there, you could have two different query models. You could cache things into memory and have that as a memory engine to query the data sets, or you could do a live query to connect to data sources. So some of the data sources are things like EMR, which is the AWS managed Hadoop and Spark ecosystem as a service. You might have a Hornworks or a Cloudera cluster running on EC2. You could connect to all those. In addition to things like relational database sources, data warehouses like REDSHIFT, those sorts of things. So talking a little bit about some of the services and why it matters in analytics and these workbench scenarios. The first is Amazon EMR. How many folks in the room, out of curiosity, are familiar with EMR today? Okay, a handful, excellent. So Amazon EMR stands for Elastic MapReduce. It's really the Hadoop and Spark ecosystem as a service. And why this is really important is the workbench needs to be able to handle a constant growing number of data sources. You might have different data formats, and you need a processing capability that elastically scales. And you don't have to worry about provisioning the Hadoop infrastructure under the covers. Amazon EMR, really great service to do this. So you could very simply launch a Hadoop or Spark cluster. You could configure, I want Hive, Presto, various applications on that cluster. And then you could elastically scale that as you get more data into your workbench and these different toolings that RK and Alex are talking about. Tableau has really great built-in connectors. So you can actually launch an EMR cluster and connect Tableau very easily to your EMR cluster. So very, very nice integration there. Really lets folks focus on the analytics rather than how do I launch a Hadoop cluster, which is a pretty complicated distributed system. The other one I wanted to talk to you guys about real quick is Amazon RDS. So, I've worked with a lot of DBAs. I was never one myself, but feel like I got very close to some of them. And DBAs, oftentimes are very focused on standing up databases, patching it, making databases highly available. Really a lot of heavy lifting that isn't really specific to the domain and the analytics and deriving insights for your organizations. So Amazon RDS is a fully managed database engine. It supports both commercially offered engines as well as open source. So you could run Oracle, SQL Server, Postgres, MySQL, MariaDB, many different engines within Amazon RDS. And what you get out of the box is a fully managed service. So you spin it up. You could set it up to be multi-AZ, which is a high availability option. And at that point, you have a database where you could focus on schema optimization, connecting it to your notebooks, connecting it to Tableau, really focus on what matters to your business. Really, really great service for data warehousing. So data warehousing is a common challenge I'm working with customers on. So many customers are faced with ever-growing data sets, and they want to load it into a data warehouse. And they want really powerful BI tools to be able to interact with that data set. RedShift, very, very simple to use, very, very performant, and very cost-effective. 3 core tenets of RedShift. And what you're able to do, just like many of the cloud services you've probably heard about so far at the summit, is it's very easy to spin these up on demand. You could spin up a data warehouse. You could load up to 1 terabyte and costs less than $1,000 a year for that data warehouse and execute BI queries against it. Very, very nice integration with things like S3 and various data sources. And again, Tableau has a nice integration with that, along with the Workbench. So the Workbench leverages RedShift, along with many of these services like EMR with Spark. One last service when it comes to kind of the data tier and some of the analytical tier, RedShift running some of those business intelligence analytical queries, is DynamoDB. DynamoDB is a fully managed NoSQL database. So NoSQL allows you to store, in this case, key value pair or JSON documents. It's very, very scalable. So you could store nearly infinite amount of data in it and still have single-digit millisecond latency retrieving your data out. So you can start very small. You can define how much read and write provisioned capacity you want out of the database, out of the NoSQL database. But then you could very easily scale that up. Again, with the workbenches, with this innovation, agility, being able to experiment, be able to bring all these different tools, and really being able to scale based on the more and more data you get, really enables some of those things. And I should have mentioned, we're kind of going down the stack on your right side. So we started kind of on the visualization side. We talked a little bit about Tableau, being able to provide that BI interface. We're going through some of the services and the analytics. And out of curiosity, how many folks in the room have a data lake initiative today? Okay, I was almost expecting more than that. Very, very common for folks to start looking at data lakes. Being able to capture your data in various forms. So you might have structured data, you might have unstructured data. You have a need to be able to collect as much data as you can to be able to analyze it. And what the Workbench leverages, along with some additional data sets, is Amazon S3 to be able to provide some of those services. Some of the key characteristics of a data lake. First, you need to be able to collect anything. So that data lake needs to be able to store transactional database log files. It needs to store streaming event data coming from IoT sensors or coming from telemetry data. It needs to be able to store large imagery, maybe from geospatial satellites. So it needs to be able to collect a massive amount of different types of data sets. And then also another key aspect is once you have it there, you need to be able to access it with a wide number of tools. So you might want to launch a Jupyter notebook, like RK was talking about earlier, and load different data sets, either directly through S3 or through things like Sailfish, which we're going to hear about later. Also, being able to have flexible access, being able to also lock down the access, and we'll talk about some of the security characteristics next. We like to call this future-proofing, putting together an architecture that knowing you're going to start something today, you might use a set of analytics and tools, but what you're using today might be very different of what you're using a year from now or 2 years from now or 5 years from now. So how can you build that architecture that you start driving insights immediately for the business problems you identify, but you're not locking yourself into the constant innovation that's in this field? Some of the key characteristics we see out of that data lake, the first is definitely the need for user interfaces. You're going to see some of the user interfaces from the Booz Allen team here shortly. To be able to interact with the data, discover the data, see what data sets you have. Rapid ways to ingest and store it. There's no use having data if you can't find it. Being able to store your data, but also categorize it and search for that data. And of course, in all industries, security is very, very important. In the public sector, it's definitely one of the first conversations we always have within our customer space. So how this fits into kind of a higher level architecture. So many times if you look at a data lake, oftentimes a data lake isn't necessarily one single service or one single component. There's not one thing that will do every function of a data lake. So what we see our customers doing through really good partners and some of our clients is being able to leverage things like S3 for object storage, leverage other services to be able to run your analytics, such as Hadoop-based analytics on EMR. You might be running Hadoop on EC2, being able to do machine learning of the data on GPU-optimized instances to be able to build deep learning or neural networks. So being able to have this ecosystem, bring your own tools, right? Bring your own out of the BYO star that RK was talking about, in that architecture is really important. So I give Tableau the credit for this slide. I really like it because it really helps illustrate the building blocks, right? Oftentimes I like to describe many of these AWS services and solutions as building blocks. And what the Workbench has really done is one approach to be able to take these various building blocks and be able to put them together to be able to start having customers deriving those insights. So I'm going to actually turn it over to RK to talk a little bit about some of their customers and then give a demo shortly after that with Alex.
Yeah.
Thank you.
Thank you. So why does this all matter, right? I mean, it all matters to what things that we've done actually, right? I mean, it's not just our conceptual idea about this life cycle. I'm going to get Alex here to really talk about one of the integrations we have actually done within the Workbench. So think about the Workbench having a disparate set of tools and capabilities and data sets that people can come and interact and accelerate that cycle. One such example is, I don't know how many of you all are familiar with the evidence-based policy making. Is anyone, just sort of curiosity again, I mean, evidence-based policy making, HR 1831, there's a House resolution that was passed. Anyone aware of it? Okay, so I didn't expect that as much. So there is the need for the research entities within the government today thinking increasingly about how do you kind of enable more data analytics on what has traditionally been done with, policy-based research. You had statisticians who were sitting and crunching, based on a problem, they could bring in data sets and do some analysis. But right now, that's going towards how can you create a data hub on which you could leverage these big data sets to actually kind of enable research to kind of influence policy, right? It's a pretty interesting thing. If you're not seen, I would encourage you to kind of go and see. A lot of the agencies that we have across the board have this kind of a need. Some of them are providing data sets, which could be administrative data sets like your Social Security Administration data, your tax filing information, which is shared with the Census Bureau. And then there's also the open data sets that's brought in, including surveys that Census is kind of putting together out there every 10 years and in between. So how do you merge these data sets? What they figured out is when you merge administrative data and survey data and open data sets, your quality of your policy-making research is pretty big. In fact, there's one thing that was recently done, and I'm happy to share this offline, where the research on is, should money be spent in kind of providing better schools in certain districts, or is it better to kind of give vouchers to actually move kids from a particular area to a better performing school district, or asking the family to move? Would that make a difference, right? So they have come up with some interesting conclusions on that. So to be able to do all of that stuff, we actually brought in and, we brought all of our capabilities. So we brought in Sailfish to curate some open data sets. We did this with it's publicly available, right, on, and I'll happy to share it offline, of what we did with the SNAP data, right, Supplemental Nutrition Assistance Program data. We found that when we looked at the SNAP participation rate, it was pretty bad across, it was very different. Some states had better participation of what we call as penetration rates or fill rates relative to the others. So when we looked at the data sets, we were trying to help the government to say, how do you make this more effective? So if you take all the data out there in 50 different states, you can't really combine it. So we brought those data sets together, curated in Sailfish. We started what is running as clusters, right? I mean, we started clustering these states based on other things like incarceration rate, education, income, land area. We started throwing all kinds of open data sets at it. And based on that, what you see out there is we clustered those states. So we did two things. One is how could you cluster, how did one cluster perform better than the other cluster when it came to fill rates? And within a certain same cluster, how did certain states perform better than the other? What are those learnings we could? And I'll give you a simple example we learned out of it. We found that in certain clusters, applying what is called as BBC, I forget the broad-based category eligibility. Certain states, because food stamps are a state-run programs, we found that if the state had an automatic qualifier program, meaning if you qualified for other benefits, you automatically qualified for food stamps, the fill rates were much better, right? This is not what people are looking going into the data, right? This is what the data said. And that had to come through this kind of analysis that we came up with very specific micro-optimized decisions. But to do that, we had to take the data that came in from the disparate sources, put that into AWS. We had to curate it using Sailfish. We'll talk about that. And then we used what is called as a data lift product, where we brought in data sets that are sometimes from different sources, contextualized, because certain zip codes data had to be contextualized. Think about it almost as a container of data sets with a microservices kind of a thing. It's built off on our Docker, underlying Docker technology, which kind of provides applications as a microservice. But this is about containerizing data, right? So think about how do you secure data? How do you provide lineage to those data sets, which data scientists care, the veracity of data. All that is through data lift. We use the open data platform, which is our big data platform, which got everything from the Hortonworks and the Cloudera and the Hadoop infrastructure to NiFi engines and whatnot. And then what the Workbench did was bring all this together. So let me hand it over to Alex to actually walk you through a demo and some of the stuff we've done here.
So I get the risky part of this because I actually have to try to do a live demo, and we'll see if it actually happens or not. But I tried it like 87 times beforehand. We'll see if it works. Just as a quick introduction, my name is Alex Hansen. I've been with Booz Allen for almost 10 years now, doing enterprise development. My sort of bread and butter is Java. Recently been working on big data analytics and DevOps in the AWS cloud. And for the past couple of years, I've been working as the technical product manager of our Sailfish product family. Sailfish sort of has basically two components. The first component is Sailfish Exchange, which is our social data curation platform. It gives users a one-stop shop to be able to identify their data, curate it, rank it in a social fashion, and then make it available to the community at large so that people are not solving the same data-driven challenges over and over again. They've already found those data sets, and the best data sort of bubbles up to the surface. The second piece of the platform, which I'm going to talk about today, is Sailfish Explore. That's our data analytics platform, and that enables users to be able to connect to a wide variety of data stores, from flat files such as AWS S3 or EFS. We can connect to relational databases. Basically, if you can deploy it in RDS, you can deploy it. You can connect to those data stores in Sailfish. So MariaDB, Oracle, MySQL, SQL Server, and what's the fifth one? Postgres. I think I covered all the RDS ones. We can connect to all those, as well as NoSQL databases. We can build custom connectors to be able to connect to those. So what I'm going to do here is give a quick demo of our Sailfish product. See if this will cooperate. So what I've done here is I've actually loaded in a data set that we can query on our ask page. This is sort of our plain English style way of being able to ask questions of your data. So all your data that's connected to Sailfish appears in here. So what I'm going to do is I'm going to type show me, give me a second here. All right, show me DC crime incidents. And what this data set is it's a data set of all the crimes that occurred in the DC, at least I think it is, from 2016. I found it on, it's like DC Open Data, I believe. And if I scroll down here, I can see, I got latitude, longitudes, I got, some other information, date, times, the offenses of the crimes. I can actually then dive in a little down here and ask a follow-up question, just start to sort of get some descriptive analytics in my data. So if I want to do counts by offense, just again, all I'm doing here is just exploring the data, trying to figure out, what's going on. We actually find a lot of people just trying to get to being able to run those SQL queries. They really like this sort of natural language way of being able to connect with their data. So I'm going to kind of go back up a little bit. I mentioned that we had this location information, so the natural inclination is, again, the next step is to sort of want to explore that on a map and see what it looks like. So we have a couple of rudimentary visualizations in here, one of which is our mapping tool. And let me see if I can zoom in here. Again, just, sort of testing my understanding. Everything as I would expect is in this DC area. Get a bunch of blobs, as it sort of aggregates, all those latitude, longitudes into a single point. So again, doing some descriptive analytics, just seeing what my data looks like. We do in Sailfish have a more advanced workflow builder on our build page where you can actually drag and drop and build workflows that you can run repeatedly, do data set joins across, relational databases and your flat file stores. What I'm going to show here is, once you've done these analytics, you want to be able to get those into a visualization tool. We've been talking about Tableau a bit here. So I'm going to go up here and select the Export Results button. And you can once you've run these analytics, you can export them to a number of different formats. So obviously CSV, everybody knows Excel. It's sort of the bread and butter of, being able to, run some basic analytics on your desktop, so you can get it in CSV. We mentioned Data Lift, which is the containerization of your data. So it provides provides a Docker container that encapsulates your data. Obviously, we can do JSON. And then we also support export to Tableau. In this case, this is an export to the Tableau TDE format. If you have Tableau running on your desktop, you could download a TDE from this page. We also have native integration to send directly to Tableau server. So I'm going to go ahead and do that. Call it, show me DC crime incidents. I'll just leave it as the default name. And I'm going to go ahead and put it in the Sailfish project in Tableau. So it's going to go ahead and build the TDE. We're going to send it over to Tableau. And then once it's done, I can actually go over to Tableau and visualize that data. So dive down into Sailfish here, look at my data sources. We've used this for a couple different things, but I can see here There is where's my show me DC crime incident. So it's over here. I can build a workbook from it, explore it a little farther and so on. I've actually already built a workbook that sort of gives a little bit of insight that you can get from Tableau. So I have my DC crime incidents data set here. Click on view. And then what I've done here is I've actually grouped by or counted the number of offenses at each distinct latitude longitude value. And then I've actually removed all of these sort of like single bullet points. Basically, again, just trying to explore where are the high crime areas in DC. If I come over here, let me see if I get that. So I have this one block here, which has 147 offenses for the year 2016. If you look at the data, look at the counts, you actually find that is twice the number of offenses of anywhere else in Washington, D.C. And if you look on the map and like actually have a real good map, you'll see that that's the Columbia Heights neighborhood. There's a mall there. And almost all of the offenses in that area are theft and burglary, I believe, which again makes sense given its sort of central location as a shopping hub. So what the purpose of this demo really was to show is just to kind of show how you can get from data stored in S3, data stored in RDS, the Hadoop ecosystem, and using the open data platform. Do some quick descriptive analytics, or you can do machine learning in Sailfish, and then get to a powerful visualization tool such as Tableau. And we did that all in, I wasn't actually looking at the time, but it was like 8 minutes. So you can go pretty quick with that integration, and it gets you from raw data, analytics, discovery in a very quick period of time. So I'm going to hand it back over to RK. He's got one more quick use case to cover. Let's see here.
Yep. Can I get that back?
Just hit Alt-Tab again.
Alt-Tab. Oh. Okay, while we get started here, I mean, I don't want to. So the last use case we're going to talk about is, so the real takeaway from here is not about just what this product does. It's about the ability to integrate all of these capabilities across the board, right? I mean, the acceleration of that data science lifecycle is going to happen, or acceleration of insights is going to happen when you're able to kind of wire these tools. So somebody asked me, like, is the workbench just about an ability to deploy a set of disparate tools? No, that's not really our secret sauce. Our secret sauce is the ability to kind of use the APIs between the tools, between the data sources, between the platforms to start moving your analytical workloads, start moving your data sets, start moving your workflows across these disparate set of tools. And it's only through that process can we tap into the speciality of each of the folks who are going to come in, whether it's a business analyst, it's a data scientist, or a data engineer, whatever tools they bring in, whatever data sets that they bring in, closed, open data, administrative data, whatever that they can pull in, and be able to accelerate this. And the last example of this is another example where we've shown you one which is a more intense data science example. The second one was more about how we've integrated product. This one is about dashboards as a service. This is something that I presented at the Tableau Summit a couple of months back, but it's for a large federal financial agency, where we've actually integrated Tableau with a Drupal infrastructure, right? So today the CIO has actually essentially become a provider of insights, right? CIOs are kind of thinking about how do they stand up a chief data officer office, and how do they kind of help business consume insights. This is one thing that one of our customers has done to actually stand up a Drupal infrastructure, branded and integrated that with Tableau, and then branded it in a way that, you know, the CFO could come in, the head of logistics or whatever could come in. They could work with the CIO infrastructure to kind of create these data sets and publish it as custom dashboards, which is branded and delivered through their choice, right? So by doing so, A, the CIO is becoming an enabler of the business. B, he's also governing the type of information that is kind of in one central infrastructure that could be done. So this was, again, a capability where these tool sets got integrated. This is a much more lighter use case. So with that, I wanted to just say thank you and open up for any questions for any of us. And we got about 6-7 minutes, so happy to answer any questions.
I wanted to get some exercise.
Thank you. My name is Tony. I'm from Department of Treasury, actually working on that platform for Dashboard as a Service.
I quote that, sir.
Yeah, so the question here is when you were going over the EMR and the auto-scaling capabilities, and you can hook it up, obviously, as a processing engine for Tableau. The question is, as your workloads obviously get larger, is there a possibility to make that auto-scaling dynamic in nature so that it's transparent to the analyst and able to address, like, peaks throughout the day and versus, shutting it off? Is it that dynamic in nature?
Yeah. So thank you. So yeah, EMR recently announced a new feature. This was a few months ago with built-in auto-scaling. So very much like CloudWatch and EC2 auto-scaling, you could define rules. So if you're running a lot of Spark jobs that have a lot of yarn memory, and so you can scale up your cluster dynamically based on those rules, saying I want to scale the number of nodes I have when my yarn memory starts to peak, and then scale back down when there's no more jobs. Or you could use the number of jobs submitted, various triggers to do that auto-scaling.
Can it also be based on like analyst query response time? If a lot of analysts are on concurrently working, you start seeing the degradation, they can expand in that nature?
For some analytics, so the question I don't know if everyone could hear, was can you do it based on analytical response time? For many of the analytics, some of the engines would require you to do a CloudWatch custom metric because of CloudWatch has some native metrics. We have some really good built-in support for some analytics, but if you run a bootstrap action and run Impala, EMR doesn't have any, it's not monitoring the Impala response time, so you'd have to use the custom CloudWatch metric for that case. Do you mind? Yep, thanks.
A quick question about Sailfish. So the Sailfish, does it hold the data, or does it just point to all the data around the world? Does it just help me kind of understand where my data is and let it be at rest, or does it look to try to aggregate it?
Sure. So Sailfish is designed to not be a data store. It can connect to a number of different databases. Again, everything in RDS, the Hadoop ecosystem, so the open data platform, or if you wanted to connect to Hadoop and EMR, you can do that. Flat files in S3, EFS. Doesn't want to manipulate the data at rest. It just provides a means of being able to access that data. And for Sailfish Exchange, which is the data curation platform, it's just providing pointers to the data assets. So there's no data storage there as well.
Hi, I also have a question around Sailfish. So what is the data normalization process? How does the Sailfish application facilitate and reduce the amount of time that's spent around the data and the normalization of the data?
So that's always one of the big challenges, is trying to understand how your, sort of the key points in your data and what are the important fields and stuff like that. Is that kind of what you're getting at, or how to sort of this is an IP address, this is a date, like those sorts of things? Mm-hmm. Sure. So we provide sort of a layer on top of the data. So when you read a CSV file, we know what a date looks like. We know what a zip code looks like. We know what a number looks like. We provide sort of a thin layer on top of the data that provides data aliasing for more friendly names, as well as enabling certain features in the application based on whether you're dealing with dates or numbers and stuff like that.
Yeah, we probably have time for one more question, and then we could step outside and take additional questions. If anyone has one more, though, we could. Nope. Okay. Thank you guys again. We'll stick around just in case folks have a couple more questions, and thank you.